everybody, I'm Casey. Today Charlie, Billy and me will teach you about the Newton's law of motion. So now I'm going to discuss about Newton's first law of motion. Sometimes it is referred to as the law of inertia. It is Newton's first law of motion. Let me give an example. You can see the car is at rest now, means its velocity is equal to 0 meters per second. It stays at rest. Here is another car, which is in motion, means the velocity of the car is not equal to 0 meters per second. It stays at motion. We can say all objects resist changes in their state of motion, then tend to keep on doing what they are doing. So the state of motion of an object is maintained as long as the object is not acted upon by an unbalanced force. Some of you have ever been tried the roller coaster? We find ourselves often pinned against the seat or feeling like we are floating off of it because the roller coaster car has decided to change the direction. But our body's inertia wants to keep us going in a straight line. This is the most prominent on the rapid change in direction or attitude.
Here against the Newton's second law. But first, what is Newton's second law? The Newton's second law is the object of the acceleration is proportional to the force and inversely proportional to the mass of the object and inversely proportional to the reciprocal of the mass of the object. The direction of the acceleration is the same as the force. Here's the formula. The formula is the force equal to mass times the acceleration. Here's an example. This is a Bully diagram. On the left side, we have the 3 kg weights. On the right side, we have 2 kg weights. If we use 2 hands to hold 2 sides and let it go, and the acceleration of the left side goes down is same as the right side goes up. And the left side going down force is 30 newtons, and the right goes down force is 20 newtons. For better understanding, we will change to the other diagram. It's much easier to understand. Here, we have the 30 newtons to go that way, and we have 20 newtons to go that way. So here's a result force. So we will use 30 newtons to minus 20 newtons. We got 10 newtons. This is our result force. Our mass equal to 3 plus 2. We got 5 kg. So now we can use the formula F equal to ma. We already know force equal to 10 newtons, and we already know the mass is 5 kg. But we have to find A. We have to find the acceleration. So we use the 10 divided by 5. So we got 2 meters per second squared. And the acceleration on the both sides will be the same, like this. But the direction is different, see? And after the result force, see which direction force is strong. If the force on the left side is strong, it will go to the left side. If the force on the right side is strong, the direction will go to the right side.
Hello guys, today I'm gonna introduce the Newton's third law. In the forever action, there is an equal and opposed reaction. The statement means that in every interaction there is a pair of force action on the two interacting objects. the size of the force on the first object equals the size of the force on the second project. Now I'm gonna draw the graph for you guys. This is the boy. He pushed the wall, and he used the 100 newtons. Then the wall will push back 100. So it's a straight. It must be straight, and because there is an equal and opposed reaction. This is very important sentence. That's all.